Okay, simple spectroscopy for Astronomy 101. You're going to build a spectroscope. This is the completed spectroscope. All right. Here are the pieces of your simple spectroscope. And 5 nuts and bolts, a spacer. This is the grid that has nanometers and electron volts on it. The light will pass through the big slit here. There are 2 types of diffraction. There are 2 types of spectroscopes. We're building this type of spectroscope. The light passes through a diffraction grating and produces pairs of colors. Here is the diffraction grating. It generates the rainbows. It always generates them into pairs. Prisms generate spectrums too, but only one spectrum. In a prism, this, right? Red is bent the least, blue is bent the most. In a diffraction grating, not only does it produce pairs, but the high energy blue light is deflected the least, and red is bent the most. So notice the spectrums are opposite. Okay, so when white light comes into a prism, it makes the colors if it's hot enough to produce visible light. Next picture. This is the dispersion angle of the prism. Red, orange, yellow, green, blue, indigo, violet. Here is a light source. Here is a slit. Here is a prism. It could be a diffraction grating. In our device that we're going to build, it's going to be a diffraction grating. In fact, this shows a continuous light, an incandescent hot light, passing through a prism and a slit, and it produces all the colors in the rainbow. This is a fluorescent light, and it produces what looks like an emission spectrum. It's a bit more complicated than that in reality, but anyway, it looks like an emission spectrum. There are 3 laws of Kirchhoff. This is Kirchhoff's first law. Continuous spectrums are caused by hot light sources. Solids, liquids, or dense gas. Kirchhoff's second law, emission spectrums are caused by tenuous, dense, excited gases. Fluorescent gases, fluorescent lights, or mercury vapor lights, they have a discrete emission spectrum, but some of their lines are in the ultraviolet. The white goop inside the fluorescent light absorbs multiple high-energy photons and re-radiates them out into the visible. That's what was happening. No, this actually is the spectrum of hydrogen, though. An absorption spectrum is caused by a continuous spectrum passing through a tenuous, not dense cloud of gas. Go back up to the previous one. Notice the emission occurs in the same place that absorption is for the same gas. Next. Next again. This shows the spectrum of helium, lithium, oxygen, carbon, and nitrogen. Now, the real spectrum are these bright lines. The continuum in the background is probably caused by some problems in the video studio when they took these pictures. Okay. Now, when you go to assemble your spectroscope, it has 2 parts. It has 2 pieces of styrofoam, a big one and a small one. You put the big one on the big end, you put the small one on the small end, and you put the 5 nuts through. And you put this through there, and this thing, the diffraction grating, goes on the end. When it's assembled, it looks like this. When you look at a light source then, like this light source, you see a continuous spectrum because this thing has a continuous spectrum. It's important that the slit that lets in the light is pointed at the light source. When I turn the knob, the spectrum gets dimmer and the blue disappears first. The red disappears last. Cooler things are redder, hotter things are bluer. This is an old style light bulb that you can actually see the filament. See how it's just barely glowing in the cherry red? Unless I turn it up, it gets brighter and brighter and brighter. Okay. In class, we looked at this spectrum right here with the diffraction grating, and we saw the continuous spectrum. When I turned it away, the blue went away first, and the red, and finally everything went away. Also in class, we looked at three. This is the
forward.
Okay.
There. Okay.
This is the helium thing. You can hear the thing buzz because there's a transformer in here producing high voltage. That's why it says do not stick your fingers in here. Because if you did, we'd have to evacuate you to security. Okay? And you look at this, you looked at this with your diffraction grating in class. I'm going to turn this off now. These are older style, less safe devices. Back in the days, it says danger, high voltage. If you touch this and this at the same time, you get shocked. You gotta have a little drama in here. This is mercury vapor. And you look at it and you'll see the discrete emission lines of mercury vapor. This is also producing lines that you cannot see on the ultraviolet. If I looked at this mercury vapor source from this distance for about a half an hour, I would get a really bad headache. So I'm not going to leave it on for very long because it puts light out in ultraviolet, which will give me a headache. This is neon, so you can see why many signs use neon. It's very pretty. And it has lots of lines in the violet, in the orange and the yellow and so on and so forth. It makes a very pretty spectrum. Now, if you use your spectroscope on this, it's very important that you get the slit lined up directly with the source. If it's over here, no light will get in. If it's over here, no light will get in. It has to be on the source. If it doesn't go through the slit, it doesn't work. The only reason in class we didn't need to use slits is because we turned off all the lights and this thing is itself a slit. That's the way the geometry works. Now that's a wrap on the spectroscope video.